What's up, y'all? What's up? How's it going? Ooh, boy. That's a pretty well put together inner core, at least on radar. It's not bad. That's not bad. Not bad at all. Well, not not good for Florida, but not bad. Not bad. I want to go on a little earlier, but I got a life too. Just watching the Celtics get another W as common as per norm, and I was just enjoying a little bit of free time, but uh, I gotta be a man of the people. Gotta be the man of the people. We gotta stream impactful stuff always, always. So there go the church bells for 12 o'clock. All right, let's get cooking. So right now we got 70 miles, 75 miles per hour, 980 millibars. They've been off the NOAA planes. I'm not gonna lie, they've been sucking a little bit with the. I mean, I don't want to say that. They've been struggling a little bit with the pressure, some of those extrapolated pressures with the drop zones. Haven't been doing all too well. We have pull up recon here. We got it head in. Looks like a little bit of a westerly wobble right there. So every little wobble matters right before landfall. Sam Hauser. Archon, I've been on Sam Hauser for a while now, my guy. I've been on him for a while. Elite shooter, best shooter in the league. Him and Steph Curry, top two shooters. But it looks like we got a little bit of a westerly jog right here. Pull this up. You can see recon going in. So we had here, and now here. So you can see a little bit of a westerly jog take place, at least from this, in the last two, uh, from last pass. So they've been finding consistent hurricane force winds around. You can kind of see in this band too away from it. Uh, Models are picking up on this little band out here producing hurricane force winds. So this is also going to come on and produce some significant storm surge as well. People that get into this band will be hurricane force winds and some significant storm surge, and that will go all the way up the East Coast. Especially if we see at the very last second, if we start to see this little movement, and even when it gets inland, it's not going to, Florida's not the state that's terrain and going to make this hurricane go fast and weaken fast. Ian's an example of that, especially the ground has been somewhat saturated, so the ground is not super dry. That makes a small difference, but it makes a difference. So we're not going to see this weaken right away. Right to this inlet here, we see storm surge come in like this. That's not going to be good. The onshore flow is not going to be good for this part of the shoreline in eastern Florida. And we already saw places like Daytona Beach up here in northeastern Florida coast that they've been taking a hit they took a hit from Ian, and they've been taking it for like 2 days now of 30 to 45 mile per hour wind gusts, onshore flow. That seawalls in trouble. I saw Cantori's been on top of it, but I'm telling you, there's going to be some serious, especially if this thing. Recon was trying to suggest even some of these winds were 75 knots. I'm not sure if there was any validity to it, but so we got a new update statement. No changes. No changes. Looks like we've had wind gusts almost to 70 miles per hour. Sebastian Inlet. So yeah, this is, if we see a little bit more intensification, this could pose not, I'm not gonna say a larger problem. The problem itself isn't like gonna go DEFCON or something, but I'm just saying it's gonna be a little bit more of a problem. in terms of storm surge. Every little bit matters. Sometimes there's certain capacities these seawalls have, and there's certain capacities some of these locations have until we start to see more storm surge problems. And maybe the difference between a 75 and an 85 mile per hour hurricane, and given the size, the pressure, etc., that makes a difference. So we'll have to see the very end. Still, let me take a look at radar here. It's still at least a few hours away from landfall, probably from official landfall. We won't see that until later tonight. But we definitely we're definitely going to see hurricane force winds before landfall, as we can see this banding going on right here away from the center. We're probably looking at 40 to 65 mile per hour wind gusts over south central Florida right now, and these rain bands pushing on shore. We're also going to have to watch tornado threat and some of these supercells offshore, low top supercells common with tropical systems on the right quadrant. So we're going to have this coastline area is going to have to watch out, as some of these will start to move here, and then we'll start to see this band probably set up like this, and then even farther north eventually we'll probably see it set up like this as it starts to get pulled further northwest with slight influence from the trough that we've been talking about over the last few streams. Landfall location. Let's take a look at I don't have an exact pinpoint, so we'll bring up the wind field in a second too, which is massive, super large, and that's why the storm surge threat is a concern, more than your typical low end Category 1 hurricane. Too much, or is it? Oh my God, what is with this thing? We're on the National Hurricane Center. Fix this. This is awful. This is awful. No, don't do that. Oh my God, this is not user friendly. This is super not user friendly on the computer. Holy. Here we go. So looks like we can pinpoint landfall. From here, we'll account for that little western jog. And then here. And then once it starts to move inland, notice it starts to move farther. That wasn't great. Sorry. But notice when it starts to move inland, or even that out a little bit more, starts to move inland, then we'll start to see the onshore flow switch a little bit farther farther north in terms of wind direction. Instead of just east to west, a little bit more southeast to northwest in terms of the onshore flow. But given it's not going to be a super fast mover too, has storm motion slowed down at all? It was 13 miles per hour last I checked, and still 13 miles per hour. So we'll just have to account for every little bit of slowdown matters. The more time over water it has, the more chance it has to fire off convection around the center. And if we take a look at satellite, we can see it had some convection firing up earlier on the center I saw, but it looks like it's still doing okay. Again, remember, we were never looking at a minus 80-degree cloud top storm here. So it's not going to take, it's a little bit of a hybrid storm, remember, but look at the size here on satellite. It looks like outflow is decent. It's not going to lie. It's just, it still has some dry air though. You can start to see this down here. We got some wind shear working against the system. So outflow on the southwest side has been inhibited, and that makes sense because we've been talking about dry air working into the system from the southern side. And if we just look at radar, you can see a lot more convection on the northern side and on the eastern side of the system than there is on the southeast and southern quadrant of this system. And even here, just dry air working. And even around the core right now, this is more of due to a lack of convection firing around the inner core itself than per se, because it looks like it's a pretty well put together inner core. It's just not a super strong in terms of the eye wall right now, but you can see a little bit more organization, it looks like, over the past half hour or so with the inner core, and that's why when I first looked here on the radar, it was kind of intriguing me in terms of the radar. Just a look on radar itself is pretty good, pretty good, well put together. Sorry, flustered my words for a second there, but pretty good, well put together inner core on radar. Just not super strong, and it's still not concerns. It's a good thing, but concerning for the development of the system to do anymore is just a little bit drier working here on the southeast quadrant, and that's what we've been, from this direction, but it's being sheared off. We do have wind shear working over here, which we picked up when we were looking at the forecast last night, and I'll show you your relative humidity. 5 days out. Back it up. It's close to right now. Notice a little thing. I didn't even really look, but I remembered from the forecast. I did look, and you could just see on satellite. But notice our dry air here working to prevent convection to really get going on the southern side. Most of our convection has been centered on this side of the system. We do not have a lot of convection firing on the southeast quadrant primarily, and that's because there's dry air and also wind shear. But it's not as detrimental as you would think it would be to try to tear apart the system and disperse the mid-level and low-level center, given that it's a little bit of dry air isn't killing this because remember, it's a little bit of a cold core mix. Cold core systems you look at are your mid-latitude cyclones, fully cold core snowstorms, big bombogenesis. Imagine, wintertime nor'easters. Those are cold core systems. Tropical systems are warm core systems where they get their energy, so to speak, from the ocean surface. That's they need warm waters to fuel these systems. So this is a tropical system, but remember, it's a little bit of a hybrid. So it's not perfectly tropical. So it's not as detrimental as it would be, as we would see to a system in the Caribbean here. And also, it's got a pretty decent size to the system too. So it's not super small. So it's not super susceptible to seeing rapid intensity changes, which means maybe it can't take off as fast as we would see a smaller hurricane if it had the right environment. But given it doesn't have the perfect environment, it's not super productive dry air and wind shear in terms of cutting down the storm and displacing the mid-level and the low-level center and trying to make this weaker. So we're not going to see this weaken upon landfall over the next few hours or so, whenever it makes landfall, next couple hours or so, whenever it does make landfall. But we're also not going to see this take off. We're just not going to see this at like 20 miles per hour in 2 hours or something. I told you, we narrowed it down from 50 to 100 to 60 to 100, 70 to 100 to 75 to 100, and we've been perfect with the ranges. Hit that 75 threshold. You can make an argument it made it a little bit stronger based on some of the recon, but we can say whatever it is. It's what's happening is just going to happen regardless. So no matter what we say, how strong it is, the impacts are still going to be the impacts. Nothing we say is going to change what the impacts are. So it's just purely for curiosity. Science is the exact perfect intensity that we try to nail down. And the National Hurricane Center tries to take pride in that so they can use it for future storms, etc., and try to perfect the track and intensity forecasts for future storms. So that's why it does matter sense from the scientific perspective, but from the impact perspective and the current time, it absolutely does not matter whether we classify this as a 75, an 80, 85, 90 mile per hour hurricane. Maybe 90 makes a little bit of a difference, but if it's regardless of 75 or 80 or 70 miles per hour, impacts are the impacts. People are feeling the impacts. They're not going, oh yeah, this feels 5 miles an hour stronger than what it says. No one's thinking that. The impacts are the impacts. So that's, the next time you see like a Cat 5 debate, I used to feel passionate about that until, you know, for now, for example, it just doesn't move me as much because impacts are impacts, and would it be intriguing from the scientific perspective to see a Category 5? Of course. Hopefully, it doesn't hit anybody. That's where my mind stands, though. So I can't, wish for a Category 5. If I'm trying to look for every reason that it's going to be stronger, then it's a little disrespectful to the people that are maybe seeing its impacts. Wanting to get a stronger storm. Some people have, especially younger kids on this platform, have a tough time trying to battle with, and those are typically people that usually haven't been hit by strong storms. So that's why a lot of the older people on this platform, like the storm chasers, that have seen this, gone through it, seen the damage, that's why they're able to filter that's those stuff out, with the curiosity for science and meteorology to see, the satellite, everything, the perspective. There's you got to be able to filter that, to a certain extent. So that's why snowstorms are awesome because you know, uh, it's very low casualty events, snowstorms, and they're usually super freak accidents in terms of what happens. It's like a tree falling after a snowstorm. It's a freak accident. You happen to be exactly where that tree was falling at that time. It's a freak accident. These are much more direct, these systems. So that's the beauty of winter storms. You never have to worry about more snow falling. And a lot of times, more snow falling is better too because people are going to stay home, stay off the roads, and not get themselves into trouble. It's usually those 1 to 3 inch events that don't have a lot of expectation. That a lot of the accidents, and the stat was, I remember seeing a stat from the Weather Channel not too long ago. I remember, you can correct me if I'm wrong, I believe the most accidents happen in snowstorms in less than an inch of snowfall because most people aren't have an expectation to be super impacted, and they think they're going to be fine. The car's going to do what they need to, but they don't account for other people on the road as well. You can control what you can control until someone else affects until someone else affects you. So it just takes one bad driver when you're out on that road, and that's all it takes. The ground is super slick too. There's not a ton of friction on that surface. Is it friction or God? Frictionless or friction? One of why my mind's tongue tied right now. But you understand what I'm saying. It's slicker surface, and it can be deceiving if there's not a lot of snow on the ground and you just see black. And right after, it's melting a little bit on the surface, but then freezing shortly after. And that's how you cause accidents. So it's really the lesser events with snow. That's why that's an advantage of wanting more snow. I don't even. No one ever has to be shameful about wanting more snow. Compared to, it's a little bit different from the scientific side. It's impressive to see these storms. Don't get me wrong. There's a little bit of just passion and curiosity when you see such raw power with these systems. But you have to be able to filter that and understand people. People can die from this very, very easily. People can die from this if they're not careful, and that has to come first, before any scientific curiosity. So I think that's a good way to phrase that in terms of how to combat, the different thoughts you have, when you're forecasting, and just generally curious about these systems. Let's take a look at radar. Let's see what y'all saying. Yep, yep, John. People are affected from these systems. Dry air safe for, yeah, a little bit. Hard to say exactly, but I've had to guess. Was we talked about the limiting factors with this system. It was in dry air, and the the amount of wind shear um, was impactful. It looks like. Where are the strongest winds now? Uh, so we take a look here. Right now, the strongest winds are along this coast, right here, where your strongest winds are. So along the coastline, even probably higher. This is where we're probably seeing anywhere from 40 to 70 mile per hour wind gusts right now. And as the eye wall moves closer, and as we get into this band right here, as this moves over, and then you got to remember some of these tornadic supercells, possibly tornadic low top supercells. These are, or even if they don't produce tornadoes, they can produce pretty strong winds. So these are capable of producing 50 to 80 mile per hour wind gusts. And then this eye wall, whatever we got going with this eye wall, this inner core here, whoever gets into this and this band as well is probably going to have a shot to see 60 to 80 mile per hour wind gusts. Um, that's where we're going to see the strongest wind with this system. And you got to remember the tropical storm force winds are extending super far relative to a category 1 hurricane expected. So you got to remember, every way you can't just say category 1 hurricane. It's Cat 1 hurricane, but large wind field. Astro tides are pretty high right now with the near full moon. We have there's different factors going on that make this a little bit different. Let's take a look at the wind history. I mean, this is such a large wind field. Such a large wind field here. Look at this. Let's look at our current wind field. It's probably something like this, maybe even bigger. Well, let me get to the current one. This is just our wind history. Started out, always had a pretty large wind field. Think about that. You could fit Puerto Rico, Dominican, Haiti, Cuba, Jamaica. I mean, you could fit all these in just like right here. Yeah, it has a. That was when I first opened up radar. I'm like, damn, this has a pretty good looking inner core. You know, not too bad. Not too bad. Let's see where we're at. YouTube, damn, you guys active tonight. Jeez. Ooh. What's up, my YouTube boys? How we doing? Or girls? Boys and girls, how we doing on YouTube? Sorry, just hurricane or snow. Just subbed. I appreciate the subscription. Oh, that reminds me. If I don't do this, the YouTube algorithm doesn't like me if I don't do this. I gotta go here. I gotta manage 4 likes. There we go. 4 likes. It's a good number right there. Given we just started streaming like 20 minutes ago. Take that out. If I don't do this, for some reason you have to specify whether or not it's made for kids. And when I stream from Restream, and I don't do this, it messes with the algorithm. Bigger again. I mean, it's large in size, but this is not it's large in size, but this is not a super strong hurricane, so to speak. Um, it's not super strong, but I don't want that to take away from the impacts. The impacts are the impacts. I don't want to phrase it in a way that's going to take away from these people. You know, we can look at what we got. Let's take a look at one of our trusted Mark Sudduth. I'm sure you guys have seen some of his stuff before. And take a look at some of this stuff. Turn up the line. No, not there. Great. 60 something, 60 miles per hour. No, that's Melbourne, still strong. Um, but those look like some 60 to 65 plus mile per hour wind gusts right there. So we got some pretty strong wind gusts currently. What's the best radar? For if you don't have, if you just want free and you don't want to use anything, and you just want to get regular radar, National Weather Service I think is a great. Honestly, the new format, I love the new radar format. Um, the best one, you want my honest opinion, there's a couple of cool ones. Weather Lab, there's 3D radar, and I really like that. Um, I almost had a sponsorship with them, but they didn't do that. So I just got a free trial, which was pretty cool. I don't use it as much anymore in terms of like posting stuff for analysis, but um, this is what it looks like. If you're curious, you do have to pay for it eventually. And then I'll show you my go-to that I'll post on my Twitter. Um, that's not that's not it. Here, this is what the app looks like right there, and then radar scope. Radar scope. You got to pay. There's a paywall initially, and then you got to pay like $7 a year or something. It's like $7 a year, or maybe it's like $10 a year. But it's if you love the weather and you're genuinely interested, it's absolutely worth it. This is what the app looks like. You get really good quality. I'm not gonna pay for it again, and maybe I'm tempted. I'm tempted to pay for it again, but I don't want to pay for Radar Scope again. For some reason, you can't link your accounts, or maybe you can, but you have to pay. They make you pay for the. Even though I already have it on my Apple iOS, they make you pay for it on the computer and the Mac again. But Radar Scope, I mean, you can take a look. You get velocity stuff, so they'll show you how strong the winds are above the surface. These aren't surface winds, but the wherever the radars, because the radar, you got to remember, radar tilts like this. It's not like exactly like that. It's maybe more like this. And radar tilts, so it's measuring what's happening at this level of the surface. Radar doesn't go like this because there's trees, and then it wouldn't be able to see. So it's measuring winds, at this level of surface, and then a lot of times in strong wind or strong rain, heavy rain, those winds come down to the surface much easier. They're able to be transported much easier. So it's good for that. It has a precipitation depiction, so it will show you, actual, rain, snow, sleet. It's not perfect, but also has correlation coefficient, which is basically picking up anything different from what's happening in the atmosphere from the rest of the atmosphere. If that makes any sense. So if I pull up one of these, is going to have here we go. So this is a hurricane. So this is not exactly productive for what I want, but imagine a tornado. There's a lot of debris. Correlation coefficient is going to pick up on a debris ball. This is a hurricane, so it's not the same. So don't get any ideas from that picture, but it's good for that. And then in the wintertime, you can also use it to pick out the rain snow line. So that's why I really like radar scope. Just bought radar scope. It's fantastic. You got to pick a 3D radar. How do I learn about these sites? I learn. Just learn is the thing with Weather Lab is it's not really that big of an app. Not many people use it or know about it. Yet, yeah, as it talks about TDS hail. Yet you can hail spikes. You can definitely pick up on a radar scope as well. But Weather Lab, it's just not really that used of an app. So not many people know about it. Maybe if I click, why does the game come up? No one. This is what it looks like. Here, you can see a little bit of the 3D radar now. It looks a little bit like that. Looks like it's not. I don't know why it wouldn't want to show everything, but there's a little bit cooler feature. Yeah, here we go. Take a look at this. So this is what I mean. It looks this is pretty cool in my opinion. I like it. Let's see if I can zoom in some. You see some of these. You get 3D radar. You look here. You can get some of these echo tops. You can see how high these echo tops go and give you an idea of how tall some of these thunderstorms are. You know, cool for hurricanes too. And you can change the tilt. So if it's 4D, is it 4D, 3D? Or regardless, I can look over. I don't know, three dimensions, whatever. Clearly it's not 4D because it doesn't say it, but it's 3D, so you can change the tilt and you can look from above, you can look from the side, you can look from the other side here, you can look from above. You can see they changed the tilt here. This one's looking from above, and you can also they put 40,000 feet, 30,000 feet, and you can see how high some of these radar echoes go. So I think that's pretty. For me, that was pretty cool. I don't use it too much more because I just don't. In terms of analysis, this is more for just for curiosity. Out of curiosity, there's not a lot I can put out in terms of analysis that is any different from what I'm going to use for radar scope. But for me, I like the app a lot. It's free to download, but I think you got to pay for some of the premium stuff. But you get, even for free, you get to use a couple of the 3D features, I think, or at least one of them. So I think it's a pretty cool app, in my opinion. You can play around, f around with it, mess around. For me, it's a pretty cool app. Yeah, radar scope. Why don't free radars have this? Well, think about it. Your weather app is just trying to do the bare minimum. Weather apps are not designed. You get the weather apps. In reality, you shouldn't use weather apps for anything other than temperature. Temperature and beyond that is not what you should. You shouldn't be using it for anything other than temperature, in my opinion. Or if it's going to be like sunny or cloudy, and even that's probably going to get it wrong. But at least a general idea. It's not going to be too effective for if you look 7 days out, your weather app's going to give you a forecast that it's going to change every 6 hours. It's just not going to be accurate. They don't know. So weather app that may look like it just doesn't know. But National Weather Channel radar, yeah, this is the same thing. Weather Channel radar is not any different than Weather Channel is just the same. The Apple Weather app sucks, John. That sucks, man. People always, bro, it pisses me off how many people show me that thing. Bro, look at and they click the weather app, they're talking about the weather, they open the Apple Weather app. I'm like, dude, are you serious? This is all you got? Like, bro, I'm going to tear that down in 2 seconds. My radar, yeah, I never liked the NOAA radar or the My radar. I was never a fan of the format on it. I just did not like how it looked for me. Visually was not appealing for me. So I never really liked NOAA or My radar personally. Just for me personally. Why can't Apple improve it? Because they don't care. They're not going to put time into something they don't want to improve. If they really cared, they could do something with it, but they don't care enough to improve it. No one's not going to buy it. I mean, how many people you can just why try to compete with the app space, spend time and energy and resources to try to make that better when they can just buy an app on there. Apple's still going to get revenue for the app that someone else buys. You got to think about that. So Apple doesn't really care enough to try to improve that. Yeah, you really shouldn't have any expectations for your Apple Weather app. They could, but they don't need to. They don't need to. They're trying to make the iPhone 37 right now. That's what Apple's trying to do. iPhone 37 and their sweatshops. That's what Apple's trying to do right now. Any suggestions for free apps? Yeah, I mean, I've gone through this before, so I just need a refresher. Honestly, I know you want free, but it's so radar. Even if you don't pay for like even if you don't pay for a pro tier, if you just pay that initial paywall for a radar scope, I think it's $7. I think that's so worth it. I think that's and you can have it for the rest of your life. You don't got to buy any pro features, and then you get really good. Oh, why did this come up? I mean, honestly, free radar. You just type in this website. If you're just going to get regular radar, the the visual on this and how in depth they get in the pixels. Watch if I zoom in all the way. I don't think I get any more parameters. Yeah, we can unplug this. I don't think I get any more parameters. But how if I take a look at this, we really zoom in here. Look how in depth some of these pixels get if it once it stops getting so blotchy. It's a little blotchy right now, but it gets pretty in depth. So honestly, this website itself is pretty good radar if you ask me. This is my anytime I need a free rate for a free radar on these streams. So I go to AccuWeather, but Futurecasts for radar not reliable as well, not super reliable. I guess the NOAA radar is decent. Radar Omega is another good app. I forget if there's a paywall initially on the app. I don't know if you initially have to pay for the app. A lot of people use Radar Omega too, and I'm not as big of a fan as the of the visual of the radar. That's just me personally. I know some people really love it. Other people have different tastes. This is kind of what it looks like. You get different overlays. You can get satellite on there. You can get 3D satellite. But you have to pay for these features, these satellite features. You can take a look. They're showing you temps here. The Storm Prediction Center. I mean, you can get this too. You can get this stuff on Radar Scope as well. You can get. You can't get 3D satellite. I'm pretty sure, but you can get some satellite stuff and Storm Prediction Center overlays. But you got to pay a lot. I paid what I get for. And I have a cool feature on Radar Scope where I can go to archive and I can go to any event I want to from the past like 25 years and I can go get radar from it. So I could go to January 2015, I could go get radar. Nemo 2013 blizzard from February, I could go get radar on that. Severe weather outbreak, hurricane, I can go get anything I want. So you got to pay a lot for that. You got to pay like $100 or something, but it's what I wanted. So it's what I spend stuff. I don't just spend stuff to spend stuff. I spend stuff on stuff I'm going to use and stuff I'm going to want. So I'm very protective when it comes to that. Weatherbug's not that great. I mean, listen, you get what you pay for. You get what you pay for. All right. We can keep talking about radar too. Oh yeah, that was a cool write up, Mark. That was interesting. I didn't go as in depth as I wanted to because it was late and I was tired, but so it was a little skimmy. My eyes were a little tired, but it was interesting. So, but if we look at current radar, see what we're doing. Getting closer to landfall. Looks like we're getting a little bit more tick northwest. It's going to pull north a little bit. Looks. Got these rain bands into the south. Remember, we got probably some 40 to 60 plus mile per hour wind gusts here, and now we're starting to get some of this inner core. We're starting to get close to, and not close, literally on shore. So we're gonna have to watch to see what some of those wind gusts reading. See if we got anything new from Mark. Refresh. I mean, there's other. I'm sure we got something on the TL. Some of these chasers. Josh, we'll get some video from him. Yeah, radar looks decent. Decent. I mean, it's a pretty large eye. See anything? Anything? Some storm surge. All right, looks like we'll take it. Nothing crazy yet in terms of images, but we're gonna get some pretty good. I'm sure we'll get some storm chaser footage from that for sure. Just found the stream. What's the deal here? Where do I begin? I don't know. I just do. Yeah. Yes, Mark. It was still gonna and a severe threat. We're gonna talk about a severe threat potentially too for the East Coast. I'm gonna dive into that. Two more. Can I please check AccuWeather radar? Why would I check AccuWeather radar? I like this radar. This radar does it for me. AccuWeather isn't the greatest, but in terms of what I do analysis. I break it down and I do analysis and try to keep it, not to like dumb it down or something, but I try to keep it simplistic. I try to explain it in a way that I try to understand the weather. So I break down stuff. I don't BS you. I'm not a direct weather. Direct weather BSs. You know, whether I don't know any of you that maybe are attached to him, but it's not good. He's not good. I don't want to like talk bad about someone that's making money, but it's true. He makes a lot of money to BS people. So this is not the channel for that. This is not the place for that. We keep it real. We actually go in depth here. We look at different levels of the atmosphere. And I'm trying to have an impact here on people's understanding of the atmosphere, especially Twitter. I have a good handle of, and my followers understand kind of what I'm doing. YouTube is such a broad space, and there's such an open space for weather currently on YouTube. Ryan Hall's doing a pretty good job with some of those live streams right now. He's clickbaits a little bit, which I'm not a fan of, but he's doing a pretty good job in terms of his severe coverage there. So I just try to be a really good. Those winter outlooks are awful. They're not accurate. They never are. He just puts the same wording, different areas, slightly different areas, same graphics, same colors. Just mixes up the colors. It's all like kind of a game of him to look at. Just try to make money. He makes money off it. It's more entertainment for him. I've looked at. It's not like I haven't looked at AccuWeather radar before. I've seen AccuWeather radar. I just don't really. I'm not a fan of AccuWeather radar. Like the Futurecast and all that stuff is BS, because the Futurecast doesn't even go off the current cast of the radar. I don't know why Puerto Rico is the first place that comes up here, but. I mean, it's fine. It's going to do well with now. Like, this is fine. It's just a different colors. A lot of the people like the bright yellows, oranges, and reds. But you can see here. This is where I would watch for potential low top supercells. This is where I would watch for a tornadic threat. For and potential severe thunderstorms with this line. This is where I watch for some potential rotation, and even if it's not tornadoes, potentially strong winds. But I just like this radar format personally. It looks like we opened up too. Looks like we opened up on this side of the eye wall. Okay, and to answer your question about what do I do here on stream as well, I stream a lot of current day events. So impactful events, especially the East Coast, especially the East Coast. Or if there's a hurricane in the U.S., it doesn't matter where it is, I'm going to stream it. But especially snowstorms in the Northeast too. I do a lot of analysis with snowstorms, really impactful weather. That's gonna impact people. I'm not a big West Coast guy. I don't know the area well enough. It's different. I don't really have a large following from the West Coast, so really large severe weather. I know I didn't do the last severe weather outbreak. I could have streamed, and I was a little busy that night, and I just didn't get into it from the beginning. So I didn't want to, and not have a good understanding of the event and try to stream something that I didn't really have a good feel on. I was just kind of live tracking some of it on Twitter. That's really all I did. So that's kind of what I do around here. Again, I don't BS you. I'm not going to BS you if I'm wrong. It's because I have science to show you that I'm wrong. It's not a thought. It's not a hypothesis based on nothing. It's not just trying to tell people what they want. I just see it how it is. I break down. We love 500 millibar. If you're just new here, I promise you, within a few streams, you can ask the other people in the chat. I'm sure they have a better understanding already. You're gonna learn these maps with me if you don't already. I'm telling you, the more you get to know it, the more self-explanatory it is, and the more you can look at it yourself. Some of these people already understand it already that may have haven't even seen it before in the YouTube chat. I just try to do what I can. Can I get entertaining? Appreciate it. Put that in my YouTube bio. Very entertaining. Thank you. Appreciate it. Look at CT. What do you mean look at CT? I mean, I just look where it's happened. And that's why I look at 500 so much. But, with this, we don't need to look at 500 millibars when we're within a few hours from landfall, maybe less than that, an hour or two. It looks like it has a little bit of intralight, right? Looks like we're wrapping this around on the south side pretty well. You can see we got some convection firing here, regardless of thunderstorms, but convection firing here a little bit, trying to get up into this. So despite this is where a lot of the dry areas, and you can kind of tell on radar, because Miami radar is definitely in range and would pick it up if there was. But still we got some stuff popping. But again, this is where a lot of the action is. We got all up and down this area, and even it extends some of these, don't get me wrong, we still got 40 to 60 plus mile an hour wind gusts extending here, but this area right now is where I'm looking at for 50 to 70 mile per hour wind gusts. And then in these potential water spouts, or just convective low top supercells, we could see some 50 to 80 mile per hour wind gusts. I think 55 to 80 mile per hour wind gusts. And then in this same with this inner core as well, we could be looking at some 60 to 80 mile per hour wind gusts. Whoever gets in that inner core as well. That's where we're looking at for the strongest winds currently with landfall. Winter's your favorite? Yeah. Bro, if you love the winter, I promise this is going to be a great place, because we're going to do a lot of winter streams. As long as Mother Nature gives us, I don't have any official winter outlooks, and I'm not going to put one out because it's gonna be wrong anyways, like really wrong. If I get it right, it's gonna be because I'm a little lucky. Yeah, we did almost a year ago. I chased that too. I chased the snow. We talked about it last night. I chased the snow on that one in November, and there was thunder snow, and I didn't hear it. It was thunder snow in the town I was. Didn't hear it. Mitch reported it. I don't know if you know Vermonster WX Mitch. He reported it. He got the video, and I guess I missed it somehow. No winter. No, I mean, if you want my winter thoughts, here's where I stand right now, and then we'll look at the flood threat for the hurricane for Nicole. I promise. I know there's a couple of people in here that want that. Here are my current thoughts for the winter. I've said this. This is what I've been thinking since October. And in the past couple of weeks, the extended part has become a little bit more not clear, but clear in terms of my thoughts. If those are right or wrong, we'll see. I think mid to late November. I said back in October. You can go look if you scroll through my tweets. I said it. The replies and people who DM me. It's gonna be colder in the mid to later part of November. So far, we've verified that part. Siberian snowfall we look at sometimes to see the polar vortex. To see, and if you look in my Twitter winter forecasting, I have a winter forecasting thread there, and it goes over why there's so much unknown when it comes to that stuff, and it breaks down what to look at with winter forecasting and why it's so complicated and why so many people BS you with winter forecasts. Because think about it. When you're looking at winter forecasts, if you live in the mid-Atlantic, one day, just think about one day can define whether or not you get above average, a below average, an average, or an historic snowfall season. It can take one day, one snowstorm, 120-inch snowstorm in DC, and your forecast is immediately wrong, bust, or accurate. When I say that, I mean you're either too low, too high. Maybe somehow, I don't know if you're too high on a 20-inch snowstorm, but either average, below average, or above average, and whatever you're forecasting, you could have potentially just went wrong just one day. So think about how hard that is to figure out. One day out of like a 4 to 5 month period. And that's why that's why I say temperature and snowfall are not correlated in winters. Not directly correlated. Indirectly correlated, yes. Directly correlated, no. So when you see like 3-month temperature outlooks, you shouldn't really hold any stock to whether or not you're going to see a lot of snowfall. Now, when you see snowfall, maybe it's not going to be on the ground for like 3 weeks. Especially if you live in the mid-Atlantic in general, there's a good chance you're never going to see snow on the ground for 3 weeks, unless you're in a really epic pattern. So snowfall and temperature are not directly correlated, even though people want to maybe try to tell you, you can be above average. We've been above average temperature-wise, like the last, I don't know how many winters. And I've had, average or above average snowfall in I don't know, 4 or 5. I think 2015 is maybe the last actual winter the Northeast was below average in terms of temperatures. And in that span, I think we've had, 4 or 5 winters that have been average to above average snowfall wise, depending on where you live, but just in general for the most part. So they're not directly correlated. And that's why I think winter forecasts I used to do them, but I just don't hold as much value in them anymore. But my current thoughts are, I think if we're talking the Northeast region, I can't tell you, I kind of can, kind of can't. This is not my expertise. For the Northeast, at least, I can tell you, I think it's going to be somewhat active in terms of the jet stream, especially in the beginning of the year. I don't know how Greenland blocking sets up. I don't know if we're going to have sustained negative NAO for a long time. I don't know how long those periods last for. Those are always hard to forecast and predict. And depending on the setup, that's how you can get a big one-day snowfall event. But I'm not sure how that's going to set up. I'm not sure how active I have a feeling the subtropical jet is going to be somewhat active based on some early indications, but it's a little hard to say. But I think we're going to have. I have trouble seeing right now. I told you. I just explained to you why some of this stuff is BS. So just take it with a grain of salt. But I don't think there's going to be any 2015 sustained long. That doesn't say a lot because that was a kind of an anomaly. But I don't think we have like a 4-week period of just below average temperatures with like a couple days. That period is like 6 weeks, but it's going to be hard, I think, to get several periods, like 2-3 weeks of just pure cold temperatures. You might get maybe 1 or 2 of those. You might see 1 or 2 of those maybe if it's a good winter. But it's just getting harder in general. I talked about it a couple nights ago on stream. So I'm not super big on temperature, but I think I don't want to say what exactly is going to happen with snowfall, but I don't have any indication yet in this region. So I guess it's a positive. I don't have any indication this is going to be super above average or super below average. Coast can be just hit or miss with rain line, so coast is a little bit difficult. Because 10 miles can make or break your snowfall season, maybe, especially like New York City that averages like 20 to 25 inches of snow a year, if that. If the rain snow line is off for one storm and it backs off, you get like 10 more inches of snow because of it. That changes your winter. So in terms of snowfall totals, that one storm. But we know this. Coast is going to mix a lot. That's just what's going to happen. There's going to be some cutters where the Midwest makes out with snowfall. There's going to be some interior runners where, this region makes out with big snowfalls, and there's going to be, vice versa. Or I don't know, vice versa, but, this area is going to make out with some good snowfalls, and then there's going to be some coastal scrapers. It's just every winter. But I have no indication so far if, it's super hard to forecast Southern New England. Super hard to forecast. That coastal area is hard to forecast. But I don't have any indication that's leading me super far to say, I'm actually going to, Judah Cohen on Twitter is a good follow for you guys. He does really good stuff. But I just have no indication yet, nothing, especially from the polar vortex. I don't have a lot to go off yet. We're going to have to wait a little bit more to see how once the polar vortex becomes more clear. The polar vortex sets up a lot of what happens in the winter. But so far, I have no indication that's going to be really above average or like super below average. So I'm closer to the middle right now in terms of my thoughts. If I had a gun to my head, I would say average, or slightly below average, or slightly below it, or slightly above average. Somewhere in that range. But in terms of snowfall, across the Mid-Atlantic and Northeast, but I don't. And I guess you could throw the Midwest in there too. But I don't have anything to lean me super one way or the other right now. And the polar vortex, if you're curious, this is where the Arctic, this is where we look at, for the polar vortex, that's not verbatim, but just in general, that's kind of where the polar vortex is located. And we look for lobes of the polar vortex to come down. We look for, one thing that has been linked to global warming. We talked about this last night. It is real. It is people do mess up with global warming in terms of how it's described and trying to link it to every single event that happens. We can't do that. Yet. You need a little bit more time to do to link it to certain events and research that needs to take place. But more frequently, we do see the polar vortex super significant disruptions happen. So that just in general, that's a fact. But for winter lovers, it can be a negative and a positive depending on where you live, because you can get really super wavy jet stream patterns. And when you amplify the jet stream, I think you can kind of infer from what I'm saying here. When you amplify the jet stream, that's when you can get big time storms to happen. Big time storms. You get deep into the moisture flow down here in the Caribbean, and then especially in the wintertime when you got cold air, that's coming on. You got cold air coming in, especially out in front, out ahead, you got cold air in place. And to meet that warm, moist air, that's where you can get big snow bands and big snowstorms. And that's where you've probably heard of the word frontogenesis possibly before, F-gen, as we call them. We have parameters to look at that, not in this region, but that's the polar vortex controls a lot of stuff. So we look for displacements in the polar vortex. We look for disruptions in the polar vortex. Full-on disruptions are not as common as displacements. We can look for also, another term is polar vortex stretches, is what we like to call it, where the polar vortex stays intact still, but what we get a lobe to come off the polar vortex, and we can get to come down, and maybe depending on the period, we can get maybe just maybe we can get a good week period of wintry weather, somewhere they can come down here, or possibly down here. We want, if we're living on the East Coast, we want, this is the jet stream pattern we want here, right here, especially if you live in coastal regions. This is what you want. If you live in interior regions, then you want something more like this. It's a little bit sharper of a trough, but you want that upper level low to move over the Cape or a little inland, so then you can get, these places to kick in. Just in general, every event, it's not that black and white always, but just in general. So typically what we look for, classic Northeast, East Coast snowstorm, we have a big high over Greenland. That's why I talked about this is a negative NAO, positive NAO, which currently in. But you can kind of look at this. Lots of troughing going on over Greenland currently. We look for our ridge out west, and then we can get the jet stream to ride on. That's a really big dip in the jet stream, but just not verbatim. And then we can get our 500 millibar look like that. Our low pressure to ride off, and then we can get big snowstorms for the East Coast. That's kind of what we look for. That's the magic go-to pattern we look for to get it. Snowstorms. Not every pattern's like that. You don't need that big dip in the jet stream to always get that to happen. You don't need two pieces of energy to always get it. A big phase. You can just get one piece. You get your strong southern vort come up, and if you have good high pressure locked in place, and then you got warm air to meet that, then you can get really, you can get some big time snowfall events like that. Even if it is a southwest flow event, meaning, we have, we typically see on radar the precip move like this, as opposed to the precip being backed like this. You ever notice that? You ever notice when the precip on radar moves in this direction compared to some storms where the radar comes in like this, and you see the bands come off? That means we have a negative tilt in our trough, and from there we can get we can get the flow to get back into this cold air locked into place, and that's where we get really big snowstorms. And like I said, there's different ways too. You can get, if you just had a system that went through, placement of the high is key, absolutely. But there's different ways you can get snow in bad patterns, so you don't always need this. But this is just the magic pattern that typically either someone produces, or if you're lucky enough to get in it, then you can get a massive snowstorm and get and produce some big snowfall totals for you potentially if the setup is correct. But there's other ways too where we can get a storm that just got out of here, and then there's another storm to come in quickly. We have confluence locked in. This is a little bit more volatile. This is what we're working with right now a little bit more, to an extent. Maybe not the one I'm going to draw up, but if we have another storm system that's coming in, and it wants to amplify a lot, but also it can't push. It can only push so far before it meets this confluence, which is going to work like a hyper to steer the storm off to the east. And then typically it's going to struggle to amplify from that point, but hopefully your northern troughs can get it done too. But hopefully you've amplified at this point, and then that's where you've. So when it meets here and it stops really taking off intensity wise, these folks will miss out more. But this is how you get the more populated areas to get into bigger snowstorms. Those are some of the different patterns. Some of the different patterns we look for in terms of trying to get big snowfall events. And so far, I don't have any indication whether some are going to be super persistent for super long. I do think we're going to have a lot of amplified systems, though. So regardless, if we're stuck in a period for a while, I think we have some indication that we're going to have some pretty amplified patterns. And if November's any indication of what it's going to be for the rest, I think it's at least, especially in the beginning of the winter. It's going to be a pretty amplified pattern, and amplified patterns you can get a lot. You can get, regardless of whether you're rain or snow, you can get some big storms to occur in amplified patterns. But then again, connecting back, I'll look at the chat in a second. But when we look at the polar vortex, I'll take a look at a second, John, for sure. I promised that I got to talk about the flood threat too. What I'm going to do is I'm going to talk about the polar vortex, the importance of that, and then I'm going to talk about the flood threat, or I'm going to check chat flood threat, and then I'll take a look at some of the longer range, see what we're doing with models. But why the polar vortex is so important? I mean, it's not exactly kind of. It's a little bit farther north, but it's cut off on the North America map. What happens is we look for those disruptions. Remember some of those patterns we look for, and we look for lobes to get sent down. So major disruptions, what happens is the polar vortex warms, the Arctic warms. And what happens is we can get, the polar vortex either stretched down, displaced like we talked about, but also there's different kind of displacement. So there's potentially, we could get a 2-week period of a displacement. It's not always consistent snowstorms, but, it's going to send in cold. And regardless of if it's sent down and we're troughing here, eventually this is going to move east, and there's cold coming in on the backside, even if it's temporarily for only a couple days before a new system comes and cuts, or not. That's not where you would. A new system comes and amplifies, and you still don't get snow, but you're going to get cold on the backside. Very cold air, not just cold, very cold air on the backside. And that's kind of what we're seeing now. Even if we don't, we're probably not going to see snow from this trough here, but we're going to lock in some of our coldest air of the season behind it. And a lot of these people are going to see some of their coldest temps of the season, if not coldest of the season. And then we can all see major disruptions of the polar vortex where this warms, and we just have potentially a 1, 2, 3, maybe even 4-week period of a really locked into place. And until the polar vortex can strengthen and reset itself, and until the jet stream, obviously it's not black and white, and it doesn't stay the same the whole time. There's obviously different variations where you can go in and out for a few days or etc. But typically the pattern for multiple weeks with major disruptions, March 2018, for example, January 2019, January 2015, I think 2017 too. I forget exactly when in 2017 was. You can lock in patterns, and wherever that pattern locks in, it's a little bit of a gamble. Obviously, we don't have control, but it can be a little bit of a give or take. It can be hard. You can either you can be logged in, you can get a really good consistent pattern, or you can be stuck in the worst pattern in your life, and that's typically where we see some of those awful winters. And until we know whether or not major disruptions are going to come, it can be hard. That's why it can be hard to predict these winter forecasts. It can throw a wrench in everything. It can throw a wrench in everything your winter forecast is. So that's why I tell you, after all this, you can kind of understand why some of these winter forecasts are BS. And their actual winter forecasts, like Judah Cohen, those are the people you should listen to on Twitter. I'll pull up his page. These are the people you should listen to, because he's actually looking at all the stuff I just mentioned and even farther beyond that. This is his page right here. I highly recommend. If you're curious about some of the stuff I was just talking about, that you give him a follow. He's been doing this for years. He's got studies. He's massive. I talked a little bit about Siberian snowfall. I didn't exactly go into depth on why that's important, because we got stuff to talk about here as well. But he's a really, really good follow for that stuff. How do I know these dates? I just do. I just do. Man, I appreciate all the YouTube comments, man. Some days are tough. In the internet, you just don't know any of these people, and then sometimes they feel like they know you based on some Twitter comments, and then they just they're disrespectful, and sometimes even on YouTube disrespectful, and just try to troll you. So I appreciate a lot of these kind comments. Even though I'm not super smart, but I know enough. I appreciate it. (2005) or 2015? I hope so. I hope we get big winter. I'm really hopeful. I'm hopeful that that's not a forecast. I'm just hopeful. I'm hoping we can get into a big time, big time snowstorms this year for the East Coast. We would love to track some of those, and then you guys get to see some good analysis too. 2015. No, 2015 was the good. A little flat for you for where you live, but really good for New England and coastal Northeast locations. So a little hard to amplify for you, but yes. And for some of the YouTube folks that are curious, I stream on Twitter and YouTube. So if it looks like I'm talking to a comment that you don't see in the YouTube chat, it's because I also stream on Twitter and YouTube. So I simultaneously stream on YouTube and Twitter. So that's why it's a little bit harder to go sometimes back and forth on the chat. But let's show you guys. I know this will affect more directly some of you guys, the flood threat that we have, and the severe threat too. We could actually be looking at a tornado threat for the East Coast associated with Nicole, and this is pretty common with hurricanes that are undergoing baroclinic processes, meaning hurricanes that are potentially forming with a trough like we have here. If we go slide here. We take a look here, right? So this is Nicole. This is Hurricane Nicole right here, about to make landfall. And what's going to happen here is it's going to start to meet this trough, which was originally supposed to be a lot more amplified, is now weakened a lot, and this piece was going to be a little bit more connected. Actually doesn't look too bad right now, honestly, but what was going to happen was this was going to be so well put together, and then we were going to see a 2 to 3 foot snowstorm in this part of the country. That didn't happen. Models were off with that, and so now what we're going to see is because it's a little bit weaker of a trough, this is going to have less influence on Nicole. This is going to, instead of, remember we talked about, it's going to take, instead of taking all this moisture, remember we talked about back in the flow, it wants to pull in this from the Gulf. So it's going to want to pull in this Nicole moisture. And what's it? So it is going to take some of it, but a lot of it now, since it's a weaker system, because notice when we look for phases, these, this, we have multiple pieces that are disconnected from our main system now. And remember we talked about confluence. Here's our confluence right here from a previous system. And what's happened is, notice all this vorticity along this line that's being sheared out. This is being sheared. So it's struggling to make it, we can't amplify the system anymore and allow time for these pieces to catch in and phase and make this really big. Now, don't get me wrong, there's still going to be a pretty big snowstorm here, but not to the extent that we were going to maybe see in previous runs. And you can see that here. We look at the P-type map. If I play this back, notice 1,000 millibars, good pressure gradient, still a pretty significant snowstorm, a strong upper level low still. So don't get me wrong. Places in here could still, work 1 to 2 feet of snow. But if I play this back, look where we were. Notice, see how far more reserved our low is, still getting going. Notice where our low was. I'm going to play it and notice how much more progressive we are with the system. Now we've had some consistency. But if I play this here, notice the location. Systems that move faster are progressive in general. Systems that are slower are more amplified. So we would look for the system to be back here if it was much more amplified. And if I played it back, notice how much, right? That looks like, whoa, that's a massive. So this is the difference between a massive, maybe historic, storm that a lot of times don't verify on models, but they're there for a quick minute or a few runs, etc. And it was supportive. The upper level low was super. We look at our vort profile here. Well, now I got to go back all the way. But notice, right, how much more reserved we were, how much slower we were with the system. These pieces were much more connected to our system. Notice how it has an actual phase, almost complete phase, compared to where we are now. Notice how much more stretched out this get, and notice the interaction with Nicole simultaneously. Nicole's going to get allowed to get pulled further west and further north quicker. Notice that's what we did here. And from run to run, this run was a little bit more amplified, a little bit slower on this run, just in particular this run. But in general, since a few days ago, the trend overall in general has been more progressive besides the last run. And so what happens is Nicole gets pulled for farther north and east. Well, it's going to get pulled a little bit more, but the rainfall, the axis of the heaviest rainfall, then gets pulled. We can just follow 500 millibars. It's gonna pull up, and our heaviest rain gets dispersed here. But our heaviest rain is this area, and then this sector, this warm sector right here, where dew points are going to be very humid, and also it's going to be warmer than it is on this side of the system. This is where we're going to worry about for a potential severe threat, because if we look at we'll keep playing this run out if I show you. Before we talk about it, notice we see an interaction between the two, the trough. So now instead of because this is more disorganized and less organized, so it's not going to be able to take as much moisture from the coal. The coal's going to be able to maintain some more of its original moisture. And now these places have an increased flood threat and also pulled farther west compared to originally. A little bit less rain, maybe too, but also this was our axis of heaviest not snowfall, but rainfall. And now pulls through. Notice it comes through, and then remember we talked about it a little bit earlier, not too long ago, about this trough coming in. This is cold air, so we got cold air that will come in on the backside of this trough. And since we would need to dig this a lot more, this is a little too amplified specifically, but you get the idea. And we would, what we would want is, we want a little bit of a southern, we want our trough like this and a southern vort out in front. And this is a phase. This is a north stream combining with the southern stream. And then what would happen is we get an upper level low to form, consolidate, close off, and then we could get an early season snowstorm. Some runs were trying to come close to that, but there wasn't a lot to work with in terms of any leeway. But at a minimum here, there's going to be some cold air working through. Notice if I pull up the temperature map here, we can take a look here and notice those warm air, right? This is, the warm surge and humidity from cold that's pulling up the coast. So all these places are seeing much warmer temps than usual for average. But notice we got this cold air rushing in. This is snowstorm. Plenty of cold temps for back in the Dakotas for them to see their snowstorm here later this week, or this weekend, I should say. And notice these cold temps surge in behind. So this is why I said mid to later November. I didn't know exactly how it was going to pan out, but it's working out pretty nice that mid to late November. This is what I told all my friends and family. Late November is when we start to see some of that cold air kick in, and notice some of our coldest temperatures of the year, if not the coldest for a lot of people, especially on the East Coast and Central U.S. Notice where this is our 32 degree line. Notice how far south we get. These are our morning lows. We even get in Georgia and Alabama, and some of these cold 32 degree or less temps. And then our severe threat, if we pull up, notice our 850, we look for our low level jet. So our winds, how strong are the winds in the lower level of the jet stream? 850 millibars. Remember, different levels. If you're not sure what the levels of the atmosphere are, right? This is, imagine 0, 250, 500, 700, 850, 1,000 millibars at the surface. Imagine that, right? And it's a vertical column of the atmosphere from top to bottom. So we want to look at, imagine this is 850. We want to look how strong are the winds at this level of the atmosphere, because it matters. Imagine like a vertical ladder of the atmosphere. If I pulled up a sounding, watch what happens. Notice how we get a vertical column in the atmosphere, and notice, right, 200, 300, 400 millibars, 500, 600, 700, 800, 900, 1,000. So when the pressure drops a lot, we get these values to come down more in the levels of the atmosphere. And that's why pressure falls, pressure drops. There's a reason we say pressure drops. Pressure literally drops. It falls out of the higher levels of the atmosphere, closer to the surface. Those isobars tighten up. But then on these soundings, right, we can pick up, this is degrees Celsius. So this is our 32 degree line. And if I picked up here, if we had moisture, we'd be cold enough to snow. This is actually decent humidity here. So honestly, if we were this is a little bit too dry, but if we were closer, I would say this is maybe a little bit of a snow squall, and then not a snow squall, but just a little bit. Let me take a look here, actually, what it's showing. A little bit, it's farther north, but there's a little bit of moisture. So that's why it looked the way it was. But again, if I click here on the sounding, this is a vertical column of the atmosphere. We can pick up on different things. And when it comes snow time, when it comes to track these big snowstorms, this is where we're going to look. Right? And here you can see this is about 850 millibars of the atmosphere. So now, for those of you that didn't know that, let me show you. No, that's just Levi. That's the owner of the website for Tropical Tidbits. Now we look at our 8. No, that's not what I wanted. Here we go. So this is, we can see our low pressure and also our 850 millibar winds. Notice, all right, so these are low lower level winds. Notice, right? Nicole makes sense. We have pretty strong low level winds around the center of Nicole. That makes sense. Remember, this is not the surface, but these are the lower level of the atmosphere. This is the level of the atmosphere, especially where we can look. If we have heavy rainfall, these winds can mix down easily in gusts. Not a problem for these winds to mix down in gusts. Notice too, there's going to be have to watch for a severe weather threat this week with this system in the Midwest as well. Well, why is this 12 hours out? Well, we are going to have to watch for a severe weather threat as well. Not as significant anymore, given what I just talked about with it being more progressive and less amplified, but still a severe weather threat to watch with a pretty potent low-level jet. But notice when we get pulled northward, all right, we have moisture getting pulled north. We have, we can look at our PWatt values, precipitable water in the atmosphere. Notice this is moisture, right? You can tell which is dry air. The green is moisture. The brown is dry air. And notice some of these values working up. Let's see. Just want to see where we are relative. It's been fairly consistent, actually. Fairly consistent over the past 5-6 runs. When we have moisture, we look for strong moisture. We look for strong low-level winds in the atmosphere. And also just we look for wind shear. We look for wind shear in different directions of the atmosphere. I don't know if I can pull up a sounding here. We'll see what we get. But we look for, veering of the winds. We look for, notice winds are in this direction. And then notice as we get closer to the atmosphere, the lower levels of the atmosphere, what we look for is these winds start to change directions. And will maybe move this way. And this is what we look for in tornadoes. If that makes any sense, I'm struggling to draw here. But we have winds moving this way, winds moving this way. And then they start to veer the other way. And we have winds then back to the east. I struggled at reading soundings too. It took some time. I still struggle. I don't know every little thing, especially severe weather. To me, I suck. I don't suck, but to me, compared to where other people, I try not to compare myself to other people, but compared to where other people are, again, I haven't taken any meteorology classes ever, so, but compared to where other people are, and compared to where I think I want to hold myself, I'm still not perfect at these stuff, but I have a general understanding, especially snow time. Snow time, I'm pretty good with snow now, but I would like to get better at severe. But I do know you got to we look for strong photographs. We look for loops, and these photographs are important. Different. I'm sure if any of you ever watched Reed Timmer streams, he's talked about photographs before, but we look for strong helicity values, meaning SRH right here. This is pretty supportive for possible rotation. This means we have some pretty strong wind readings. That's surface level. I just want to keep it surface level. We have some pretty, in terms of analysis, not the atmosphere, literally. And so basically these photographs are plots of winds at different levels of the atmosphere. And when they get really loopy like this tends to mean we have, veering winds and winds rotating in different directions in the atmosphere typically when we see this. So photographs are a good indicator, and also just the soundings in general we can pull up. I don't know, this in general seems like a decent profile, vertical profile in terms of for severe weather. And notice PWatt 1.8, that's pretty ridiculous. Not like record breaking or something, but that's a really strong value for the Northeast in November. That's a really strong value. That means whatever rainfall comes, regardless, even if it's like a yellow or orange DBZ, there's going to be some pretty strong rainfall rates. And notice how saturated we are in the atmosphere. we are, I mean, I didn't draw it perfectly, but our dew point is on top, on top of our red line, which is our temperature line. Our green line is our, you can barely see it because it's so on top of our red line, is our dew point. And we are super saturated in the atmosphere. This is important for snowfall too. We want our atmosphere to be saturated to get really good snowflake production and big time snowfall events. But especially in severe weather, you need strong moisture values, and 66-degree dew points in November is maybe record breaking. Honestly, that's a pretty strong. This is a pretty anomalous event relative to usual. So this is a big this is a big time event in terms of, maybe, I don't know, impacts. Still a little bit hard to say, but it's going to be unusual to say the least. It's going to get pretty warm, 60s and 70s in November. Not usual. Humid 60s and 70s too. Like, it's gonna feel like a June, an early June thunderstorm day, maybe, is what it's gonna feel like. But regardless, we're still gonna get some mixing of these winds, even if there isn't a big time severe weather event, especially on the coast here. I want to go one smaller. This is a little too big for the pen tool. I think here is going to have to worry about maybe some 50 to 70 mile per hour wind gusts, and then in general, 30 to 50 mile per hour wind gusts across the area are pretty likely with this event, primarily to the east of the low pressure too. This is what's left of Nicole, and you can see it's still like a 995 millibar system because of it's been able to use that trough to the west, kind of interact with it and then become a bit stronger. We call it a baroclinic interaction. And that's why it's able to intensify. And notice now, since this system is taking over, it's pulling in all this moisture now. Notice all this moisture. This is connected. This is not connected. So remember, this is moisture that the last system was pulling, and you can see it two different ways. It's two different systems that are starting to combine into one. And it's not how it works is you don't get mega systems when two systems combined. There's a trade-off, there's sacrifice. It's not as black and white as, two systems make big one. A lot of people think it works like, it doesn't work like that. At 500 millibars, it's a little bit different. But it's much more complex at 500 millibars as well. I mean, it's regardless, 500, it's the atmosphere. It's more complex than two systems make big one. To sound like a caveman. Tarzan loved Jane. That's basically how I made it sound. But notice we have two different systems. The pole pulling in moisture. All right, it's creating its own moisture, and it's pulling in some moisture too. With this, you can see a little bit of a pressure gradient here. Strong winds out far away. That's why I have such a strong big wind field with Nicole, just pulling in moisture as well. This system here, this Midwest, and it was really stronger and more reserved originally, so it was pulling in much more moisture and then preventing this it was sucking off some of the moisture from here and preventing Nicole from making as big of an impact out in this part of the region models were trying to save in terms of rainfall. But notice we play this out. You can start to see our stream interaction, lack of stream interaction between these pieces, this becoming very progressive and not being able to intensify anymore. No more amplification. Confluence up here. So now this is becoming super strung out. And our moisture source pulling in from here is not as strong as it could have been. And now these two are going to combine a little bit to an extent, still disconnected, but have definitely an interaction, to say the least, definitely a stream interaction. And then now Nicole, look at all this moisture it's going to pull in. All of this moisture. Look how much moisture it's pulling in. I'm telling you, some of these rainfall totals may not be good enough. When I say good enough, may not be highlighting as bad as this rainfall event could be. I mean, this is such a strong moisture feed. I mean, this is a ridiculously strong moisture feed. That Nicole, whatever we're going to call it at this point, is pulling into this system. That's a lot of moisture, and this is tropical. Tropical moisture is more potent than just regular severe thunderstorm moisture. It's able to obtain more. Every water droplet is a little bit more potent to keep it at a surface level. It's a little bit more potent. So tropical events, typically you don't need to see red DBZ on your radar. You don't need to see those red radar echoes to get significant rainfall totals. You can be in like the yellow on the radar and still get heavy rainfall, even though it may not look like it's falling as hard as maybe that red radar echoes on the severe thunderstorm you get in August. But you're getting more rainfall because the atmosphere is super saturated, and each water droplet is just a little bit more potent. So I think this is potentially models are underdoing some of these rainfall totals. We can take a look here, what the GFS is showing. I mean, every model is a little bit different, but you get a general idea. I don't think these models are drastic enough, ridiculously drastic, but I mean, I'm sorry. I don't think 2 to 3 inches is doing this justice. I don't think it's doing this justice whatsoever, in my opinion. I think where there's going to be like some 4 to 6 inch totals in here, at least, maybe more. I'm sorry. Tropical moisture with that big of a moisture feed, I lean on the bigger side in terms of rainfall totals. I mean, look how long we're raining for, right? There's heavy rainfall in places for 6 to 12 hours, maybe more. I don't know. This is when we start to look at the severe threat too. There could be a couple rounds for a severe threat here. Right here, you gotta look for a severe threat, and even if no severe threat, you gotta look for maybe some 50 to 60 mile per hour wind gusts, because these are some strong low level winds, especially if we have anything to mix this down. Let's see what we got here. Yeah, that could be a severe setup. I mean, I know it's a severe setup. I'm just looking at this, trying to look at it without any previous knowledge to what anybody else compared to what anybody else has said about it. Because I haven't really broke it down myself yet. I've just seen some tweets about it from people, and I generally know what's going on, but I haven't dug really in depth on the potential severe threat for the East Coast. Where do I want to go? Here? Like anything good? No, it's not going to show me anything good. Let's see if the Mezzo's got anything yet. We can take a look here. Maybe just try to pull some soundings. Yeah, we do have a little bit of a notice. NAMs. This long range NAM is not great. I'll preface by that. And for some of the new people here, you're gonna learn naturally about what are the good models and what are not the good models. But is it not gonna give me? No way, it's not gonna give me sounding. Seriously? Are you kidding me? I gotta go to Pivotal. I gotta go to Pivotal. pull it up here. Mm-hmm. 57 hours out. Let's pull it up. Let's pull it up, baby. Let's do it. And I'm going to go straight to the radar because I just want to get the soundings. And I might take a box sounding in a second, too. Notice marginal severe, but if I zoom in, the matches are. You get on pivotal, you get some matches, and tornado. In terms of historical, some of the analogs it has for soundings, it pulls up previous history and it compares it to past matches in terms of potential, what type, tornado, severe, hail, how big, or if any hail at all. And the one match it came up with, it's a loose match. The one match it came up with was tornado. And we can see a little bit, not super. What we look for on photographs when we look for tornado events, we usually look for, wind to be super, like wavy and out. And this is a really strong photograph look where the winds are super, super juiced in the atmosphere. We're very saturated. We have a couple of spikes, so maybe not big enough maybe for hail, but we're super saturated, really, really well saturated. We do have some veering of the winds. Notice our winds start here at the top of the atmosphere, and then they slide here at and towards 500. We're here, and towards 850. Then we're almost vertical with our winds, and then we're starting to back these winds to the east at the surface. And that's what you look for. Because remember, thunderstorms, when we look for tornadoes, we look for rotating thunderstorms. So we're going to look for winds rotating at different levels of the surface. And the stronger those winds are, the stronger the rotation can be. Stronger, the higher risk you can get for tornadoes. So I'm not wishing for tornadoes. I'm just figuring out where I can look for to potentially see the potential tornado. And currently the atmosphere is a little bit capped too. So I'm sure you may I don't know if I'm sure, but heard potentially is what we look for potentially sometimes is there's a cap on the atmosphere. And that can sometimes prevent thunderstorms from initiating, even though the atmosphere might be great. It can prevent thunderstorm initiation, and that has been a big reason why some of these thunderstorms have busted in the past. Here's one thing too. Instability is important. So notice our cape is only around 70 to 100 from the surface to the mid levels, at least at this sounding point. Remember, this is not verbatim. This is just what models are showing right now. And we can pull another sounding here. Cape's a little bit lower there, but a little bit more veering, different, a little bit more loopy. This is contaminated, this sounding though. Maybe if I pull it one more. That's a quick moving storm. That's a quick moving if we're already done. Notice, this is good. And notice here, if we look at the analogs, again, you got to do every new event is a new event. But if I pull up these analog soundings here, notice we got 3 loose matches and they're all tornadoes. So this is a potential low top tornado threat in terms of for potential. I don't want to say tornado outbreak, but we could be a localized tornado outbreak here potentially. But notice these are some pretty strong values. Notice I forget exactly. I'd have to look into this. Why do I not? Man, I haven't looked at photographs in a while, but this is 16 knot winds. Jesus, is this what level the atmosphere is this? I'm sorry, I need a refresher on photographs. This is basic stuff too for severe weather forecasts. It's just the doggy right there, sniffing. Here, lie down. Good boy. But notice here with the photographs, we have some pretty strong wind values here, and notice some of these a little bit loopy here in the photograph. That's what we look for. Some of the turning of the winds for a potential tornado threat. It makes sense based on the analogs, and it also makes sense that these winds changing different directions in the atmosphere, and not to that extent. I'm just trying to over exaggerate a little bit too. For example, this is what we look for. Pretty saturated moisture again, all the way up, 65-degree dew points. That is more than supportive enough, even in the summertime. That's more than supportive enough to get strong, let alone a tornado. You can get strong tornadoes with 65-degree dew points. 1.7 p-watt values. That is also very good. And then look at Cape again. 70 to 76 at the surface, which is not a lot, but we have pretty strong wind shear. You got to remember too. So just a little bit. We're not going to need a ton of instability here. We're not going to need a ton of Cape to make worth. Maybe we need a little bit more Cape to get a more enhanced tornado threat, at least on this specific NAM run. To be clear, this is not the verbatim forecast. This is this model run. I'm gonna have to look at different model runs to look at the severe threat, but this is just what we're looking at on this specific run of how it's trying to predict the atmosphere. Mid-level Cape is a little bit higher, so a little bit higher in the atmosphere. We have 160 in terms of our Cape, and that is definitely, it's not amazing, but it's supportive to be able to get a potential tornado, because we have, remember, shear is more important than instability. You need instability, so you can't have it without it, right? It's like, imagine if you're trying to build a really good team, right? You need your role players, right? You need your role players on your team, but you got to have your star players. Your star players is what win you championships in sports. So if I don't have my stars, then it's going to be hard. Now, I don't want to make instability seem like a role player when it's really key. But role players are also really key as well. And this is key for getting thunderstorms. Instability, however, wind shear is the biggest thing. Wind shear and moisture, I think, are your two highest. If you can have a little bit of instability with a high moisture event and really strong wind profiles in your different levels of the atmosphere with turning of the winds, you got to remember as well that's what we look for potential tornadoes events, or just a tornado to occur in general. And you got to remember the area we live in the Northeast. It's a little hard to get tornadoes here. Just, it's not a typical severe setup spot. Different than the plains in the South. How are we doing here on YouTube? I know I haven't checked the chat in a while. Virginia rainfall, PA rain. Looks like he's back. That's fine. Flood threat in Mass. There is a flood threat. It's a little hard to say specifically yet. Sorry, my voice just got out on me. But there is a flood threat in Mass. Why is 850 millibars the best option? It's just for what I was looking for in terms of the wind. Though 850 geez, my voice just went out there. $850 millibars is is not most important, but important for severe setups to look for. You got to look for the low level jet. How strong are the winds in the low level jet? And that can typically define a lot of severe setups in terms of how strong, some of these outbreaks can be. And that's why we look there a lot of times. Looks like we're getting closer. Inner core looks decent on Nicole right now. See, we got recon. We had a recon update. Looks like it's holding steady in intensity. I mean, it looks like there's someone in there. Unless the YouTube chat maybe died or something on me. I don't think it did. I think people just got tired of listening to my voice after a while. I can't blame them. It looks like there's one person in there in the YouTube chat at least. New subscribers. There we go. Appreciate the new subscribers. How are we doing on satellite? Oh, that is interesting. Look at it right before landfall. A little bit of rotating convection here around the center on the north side. A little bit too on. I wonder if this is land friction here on the south side, but maybe a little bit there too, potentially around the inner core. Definitely got some convection firing up on the northern eye wall right now. I'm curious, National Hurricane Center, any update? 980, 75 miles per hour, so nothing super different. Okay, that is the actual read. Seeing if we got any anything. Curious if we had any live coverage. Let's see what Josh has got. What was our boy Josh? Nothing. Something. No. I'm sure I'll have some video out eventually. Eventually, I'll have some video out. The convection, though, definitely popping here on this north side. I wonder how much radar is responding to that. It looks like it is. It looks like pretty well put together eye wall on that north side. I was not expecting this well of an inner core. I mean, you could argue this is what an inner core of a 100-mile hurricane could look like. It's obviously not 100 miles an hour, but maybe this tries to get to 80, 85 miles per hour before landfall. It's going to make landfall within the next, within the next 60 to 90 minutes. It looks like so. Not a lot of time, but sometimes storms don't need a lot of time. Just quick bursts and a little bit of land friction right before landfall, and it's all it needs to just intensify a little bit. Remember, we set around 75 to 100 miles per hour. It's at 75 right now, but we'll see what National Hurricane decides to do at the 2 a.m. But it looks rather impressive on radar. I'm not gonna lie. November 10th. Wasn't expecting to see this on my radar in Florida, regardless anywhere in the U.S. Convection on the south and southwest side is not bad. Not bad. It's just the southern, this southeast quadrant. So remember, the dry air's coming from here, but the way the wind shear is, it's not wind shear is not blowing this way, so it's not going to dry up. This convection here, wind shear is coming from here, and it's pushing dry air in this way, which luckily limited intensity to an extent, but the 5 to 10 miles per hour isn't still gonna increase impacts here. So maybe instead of 60 to 80 mile per hour wind gusts in this eye wall, we're looking at maybe 70 to 90 mile per hour wind gusts in the eye wall instead, potentially. But with some maybe very localized spots of 95, 100 miles per hour, if this is trying to get to like 85 miles per hour. But it's still yet, it's none, I should say yet, not to take away from the impacts that are happening away from the system with onshore flow. It's not to take away from those impacts of consistent onshore flow for hours, which is producing some significant storm surge, and also the 40 to 60 mile per hour wind gusts that are occurring inland as well, and will increase whoever gets into some of these rain bands around the eye wall or close to the eye wall or in the eye wall is going to get into some places inland are going to get into some 50 maybe, I don't know if that's verbatim, but 50 to 70 mile per hour wind gusts possibly. That is and this thing's taking off right before landfall. You got the blue check mark. Good. Strong winds too. Let's check. All right, we'll call our stream. I appreciate everyone that came in. Um, I appreciate the new subscribers. I appreciate the kind comments on the YouTube channel, especially. You know, the more the more winter we have to track, the more we'll be doing this after Nicole as well. Especially we have a severe threat to watch for with Nicole, so maybe we'll stream that threat as well potentially. But I'm liking the direction we're heading here on YouTube, which is very nice. I'm glad people. This is finding people, and excited to see what direction we head with YouTube. So and Twitter. Yeah, excited to see what direction we head with Twitter this winter too. With all the new folks that have come on since the end of last winter and the beginning of the new winter that come on board as well. So I appreciate it. All right. Well, yeah, I really do appreciate it. So we'll call it a stream now. I'll stay a little bit active on Twitter for a little bit, but calling it a night for the stream for right now. So I appreciate it. Again, I appreciate it, and